Hello world, Augustine Cortez coming live from Web3, and today I want to talk about a field that I hold in extremely high regards. It's a field that progresses humanity forward. It's one of the most difficult fields to learn in my opinion, but it is extremely important. And before I started recording this video, I read a really good article that reinforces this viewpoint I have upon it because it's necessary. It's understanding what's happening under the hood, especially if you're in Web3 and you're building and you're doing essentially anything technical. And this is the field of engineering. So engineering is a combination of a philosophical perspective of an approach, how you should do things from an engineer's approach, and the execution of engineering where you have processes and it's objective, where if you're going to build a bridge, you're going to engineer bridges, you don't think it's going to work. It has to work. Lives depend on it, and it's a process that there's no going back. So the field of engineering is one of the most important areas, and it's an area that I'm definitely underdeveloped. Growing up, I actually had an idea of idolizing the possibility of working in astrophysics. I thought like that'd be amazing to study stars and learn that, go to NASA. Like, how does it work? I was always very curious, but I was young. I was maybe 8, 9 years old. And I'm not saying this for sympathy or victim mentality, but I literally put that possibility, that dream in a mental cubby because I would literally say, oh, but that's not for me. I'm more of a person that does labor. I'm more of a person that is probably going to do something that I'm just not smart enough. I would literally think to myself like that. I would limit myself of what my capabilities were. And it's very common for minorities, people, who don't come from a background that exposes them to how things are done, and also being first generation, all the variables kind of position myself to mold myself in this form of thinking. But now being an autodidact, anyone can learn anything. You just have to dedicate the time, develop your principles of understanding, and have a linear understanding of cognition. That's what engineering is. It's a beautiful process of linear understanding. With engineering, you have to understand the first principles of what you're doing, and then you test it very, very effectively. And I read a great paragraph that I want to share with you that pertains to Web3. And it's actually called Token Engineering 101, Why Engineering is Necessary. And this is by Michael Zargam, who is a very, very, very intelligent person, works with tokenomics, ethics, AI, I believe, and complexity systems. So he has this introduction paragraph that goes as follows. The ideation stage of a blockchain project is intoxicating. Raw creative power is thrown against the wall in the form of whiteboard drawings and essays. Narratives around these ideas crystallize into descriptive models that capture the imaginations of investors and future users alike. So what this paragraph is introducing is that ideas are intoxicating. And if you can translate these ideas into an algorithmic or an engineerical position, then you can test it out. You can rigorously test this theory and do a scientific process to validate the functionality of it. And I want to bring this up because as a person who didn't grow up technical, didn't take advanced math, didn't position myself to develop further in engineering and STEM entirely, it could be an extremely overwhelming field. It's not easy to pick up, but it is possible. And I just want to make this video to showcase, have bravado, understand that it is a big field, give it the respect it deserves, but don't shy away. Do not have the limiting mindset of saying, I can't pick it up. I can't become a developer. That's another narrative I had for myself is, oh, I can't be a developer. I'm not a coder. I'm not technical like that. I don't code to that extent, but I understand programming, front end, back end, environments, networking, how this internet, excuse me, this infrastructure works. So it's the same process with engineering. Um, might be even more advanced, but everything I learned in programming, it's a STEM field, so I can translate that form of thinking. And also the form of thinking with engineering is very practical. And being a practical person, you find the core elements, build those first principle understanding, and progress with it. So it's very exciting to adopt a form of thinking, and then you can bridge it over to another field or domain. And the area that I want to focus on is token engineering, where it's a study of really economics, social science, and then you have hard science with algorithms and formulas and math, where you have a theory and you are trying to program human beings to do a protocol which is backed by a certain type of algorithms, and you have to have certain expectations to try to be met. And you deal with the complexity and you have to make it work. So with the area of tokenomics, I'm taking it very, very serious. And one of the fields I do have to develop is my engineering and my analytical process to write algorithms, have a linear form of understanding, and operate as an engineer, because it's time to advance to this point. You can't live in theory for this game, and you do have to have that background to execute your judgment. It's no longer about ideas, right? How the paragraph says, ideas are intoxicating and you can run with these ideas. And when it comes to translate and put them into a map and plan, engineering is going to be a good friend. Engineering is going to be necessary. And the mathematical process to get there is not going to be easy, but it's totally, totally doable. And math and engineering solve one of the biggest problems in the world. Take a look at Ethereum. It's proof of work going into proof of stake. Bitcoin was a security algorithm built on top of cryptography, a bunch of STEM innovations, and Bitcoin is now 2 trillion plus market cap, and it's solving accessibility to capital for the unbanked, and introduced the blockchain. And Ethereum built on top of that further, introduced smart contracts 2018 and power of computation in a decentralized manner. So all these inventions were built thanks to engineering. And we're at this point now that we got to move at the highest playing level, and it's a skill, it's an attribute that's going to be necessary. All right, so just wanted to share this thought process. I know Web3 is it's already overwhelming enough with everything that's going on, right? With trading, DeFi, finance, NFTs, and programming smart contracts, tokenomics. And you might not know where to stand, and you might say like, okay, Web3 is cool, but I'm not a builder, I'm not technical, I'm not an engineer, I'm not a programmer. Do not adopt that philosophy. Like, if you're passionate and you're curious enough, say, I'm not in this level of understanding yet. Let me put my head down. Let me advance my form of thinking and understanding. And you will get to that position. And that's the essence. You can learn anything. You just have to understand a linear form of thinking. When you do calculus and trying to solve for integrals, you're just working with algebra, you're doing math, you're doing formulas that you build step by step, and then complexity gets introduced, but you're still following a step-by-step process. You just got to understand what you're doing. And you'll be surprised how applicable these form of thinking are exercised in real life. All right, but that's the premise, is don't shy away. If you want to learn, dedicated time and energy, develop that form of thinking, and it'll be a good form. All right, so with that being said, I shall see you tomorrow. Thank you.